Okay, so this is my final sprint. Off the bat, I'm going to mention I know of one issue with it right now. That will be fixed for next quarter. It has to do with the alarmables and how they deregister. So right now I can shoot an infinite amount of bullets and they don't destroy. So I'm gonna just let you know that for now. So when you're grading, and I will go through and start at the top of my engine in the asset managers and go through all of that. First thing I guess I will do is show you the game. The God camera is in there, and then I have an enemy that moves towards you on a counter, and that's basically the sample scene along with the stitch in the corner, which would be like your UI for, like, let's say a map or a health bar. I stretched out the plane you're also on. So there's the enemy, as you can see, he just sort of creeps towards you. Same thing, the collision does work. There, and then as you can see, I can now move all the way around now because I had fixed that issue from before. But yeah, he'll just shoot multiple bullets out that won't die, which is something that, and it does not follow the rotation of the ship, so it'll shoot out straight. That's something that I know is in there that I'll have fixed for next quarter. And the scene change does work, so I can hit E and it switches to a new scene, no God cam, and that's about it for that. So now I'll go through all of my code to show you what I've done. So here is the .h, the image manager, add image, get image, it's a singleton, and then the public or private versions of the image map, which is it's a map for the image. The private versions of add image, get image, the CPP, where it's doing everything that needs to do. Model manager, same thing, it's a singleton, has the map for model map, private add model, and two different add models, one for pre-made models, one for just normal models. This one also just gets a model. So then the public versions of all of the functions. Then in the CPP, the code that runs it all, so it gets the file name, terminate, gets it out of the list for the destructor. Shader manager, once again, same thing, singleton, map, private versions, public versions. These will mostly be the same, so I'm going to run through these sort of quickly. Same thing as before, it does the same thing as all of the other ones. Same thing with texture, singleton, same thing as before. Scroll down that so you can see it all. So that's the asset managers. Then in the camera manager, so Align 16 because I was having issues with that, but then it has a default camera for 3D and a default camera for 2D. It has your camera position, rotation, and then the scales for going up the direction it's looking forward, how fast it can move in the rotation. Setup is that's the constructor. Then it has a get camera and get camera 2D, and then it sets the default camera. So then in here it's just runs set default camera, so it sets it in the constructor, returns the camera that you're getting, and then see the set default camera. It does all the math for how the camera will move with both the 3D and 2D camera. Here was the namespace for the colors. Very simple, just namespace colors. All the colors that was in the graphics, I was able to just copy them over. So my engine has a full list of colors that you can get from. The command patterns, it gets from alarmable and a struct from alarm info. There's a special constructor for setting everything up, and an execute function, and then the different variables that we need. So this sets all of the different variables that you have, and then the execute runs the execute for deregister, because this is the deregister alarm. In the .h, same thing, special constructor, variables, setting them all, and then executing. This is the command collision, so this is a template class. The .h was just defining everything here, setting it in the special constructor, executing again. And there is no .h's or CPPs for these because they are template classes. And that just does the execute there. So in the actual collision test command, once again, since they're derived from like the template classes, it just executes the object, because this is the base one, I believe. In the test pair, it gets one collection, a second collection, the constructor, then it executes running a test between two different things, and then the self is the same thing. It only has one though, so it tests the self between itself. The draw, same thing, deregister special constructor, setting the variables, and then execute. So in here, setting variables and executing out. Same thing with the register, setting variables and executing. Game objects, sorry, that was the CPP. .h, special constructor, everything same as before, just setting up variables and with a special constructor, and then executing them out. Same thing once again, just there's the special constructor setting all the variables, and then there's the execute function also. I'm going to run through these sort of quickly because yes, they're all just the same. Variables, setting variables. You can look at the setting of the variables there. Many of these command patterns are just the same because it's the command pattern that we needed to use. Special constructor, execute, all of that. Update, same thing. And then on the command base, it just runs execute. Execute's the only thing that it does. So everything can derive from that. Let's see, game object. Probably get through game object in this video. So the alarmable CPP, sorry, .h, has an enum, so it knows if it's registering, deregistering, pending, or pending deregister, and which alarm it is. So for the public here, it's just, these are the different alarm statuses for registration alarmable. The different alarms 1 through 4, or there's 5 of them. Getting the alarms, setting the alarms, stopping the alarms, triggering an alarm, setting an alarm, setting reference itters, and then the different reference itters. So in here, there's a lot of switch statements for it's checking the switch statements to see if like the alarm has which alarm is being called, and then it does whatever's inside that case. So you have alarm status 1 for that. Setting the alarms, same thing, setting it to the registration. Right here, it is stopping an alarm. So it's doing the alarm deregister. That alarm 0 is deregistered. Triggering an alarm, setting an alarm, setting the reference itter, and then doing the map of the reference itters. The alarm manager CPP or .h gets it from alarmable, and the enum setting alarms again. It has the struct which is just the information about the alarm. Parameters, public. So this is processing the alarms now and then registering and deregistering. So in here, here's where it's deregistering an alarm. Here's where it's processing the alarms, making them run and do all of that, and then it's registering an alarm there. Collision. So the collidable.h does not have a CPP for this. Does just this for now. It's called collision from H file. And then it's checking, like if this gets called, then it will be like, did you forget to overload it? The deregister for the collision because it's a template, and then here's another template for collision registering. This gets the B-sphere, sets the collider model, updates the collision data described by the material of the matrix. Sorry, not the material, but by the matrix. And then the variables that are needed. And then in the collidable manager, it is processing the collision tests of set collision pair, and then set collision self, and then it does a cleanup. In the collision volume, it does computing data, and then intersects with something else, and then intersects with something else also. So it's checking like those intersection points. And then there's nothing in there since we didn't use the volume one yet, but and here once again calculates the data. It gets the center, gets the radius, then it intersects again. But in here we have it computing the data of the B-sphere that we have. We have it returning the center, radius too, and then it returns the intersect of the see if they're intersecting. So that's going to be all for my first video, and then the second video is going to start with draw.